everybody, welcome back boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. And in this video, we're going to be working on that SOL review guide, and we're working on that 8.1. So we're going to be comparing and ordering real numbers. And what that means is you can either have ascending order, which is going up the staircase. So again, if you're saying we have a staircase, something like that, we're saying we're going up the staircase for ascending, and we're going down the staircase from least to greatest is ascending, descending is greatest to least. Also make sure you can use that Desmos calculator, because what I'm going to do a lot of times is change all of my values to decimal form first, and then I can compare them. So make sure you can see those things to know, hints, tricks, and those Desmos guide. So for number one, it says which of the following could be placed in the blank to make a true statement. So you're comparing a couple values here. And so what I could do, again, I could say this is about 0.66 repeating. And I can say, all right, what are some values that we know? Well, for scientific notation, a couple ways you can do it. You can either use the Desmos calculator, which I'll show you in a second, but anytime you have that exponent, make sure you are circling it, and we're saying, okay, is that exponent positive or negative? It's negative, so it's going to be going to the left one step. So we're going to move that decimal one step to the left, and so this is going to be equal to 0.65. You could also use that Desmos calculator, type it in exactly as it looks. So we have 6.5, and then we have times 10, and then we have, use that exponent button, A to the B, and you'll notice how the cursor bumps up, and we have -1. Another way to do it. All right, so we're saying, okay, it has to be greater than that 0.6 repeating, but it has to be less than 0.77. So as we're going, we could say, okay, it's not going to be A, it's definitely not going to be B, because we're comparing those values. What about that next one? What's 3 over 5? 0.6, which is still not true. And then we would say, okay, well, I know that 0.681 is greater than 0.6 repeating. However, it is less than 0.77, which is what we're looking for. For number two, it says which correctly list the number, or lists the numbers in descending order. So again, that's greatest to least. What I like to do for these, anytime it gives a list of numbers like this, I like to use this kind of setup, so make sure it's on screen for you guys. So it has something like this. What I like to do is first I have my original form, then I convert them to decimal form, and then I put them in order in original form. So we're saying, since we're descending, we're going to be going greatest to least. And what I can do is this sheet of paper. I can list my values, so again, I can just say, all right, square root of 2, I have 1.3, I have 1.3 repeating, 3 over 2, and 15%. All right, so let's change these values to decimal form. What you want to do first is I want to place those decimals down first. So I want to say, okay, I have a decimal all in the same column. That way I know which values are where. So I know that for sure this column is going to be my tenths column, and this column is going to be my ones column. Again, that's based on those place value columns, so make sure you can review those. So let's get these values in decimal form. So I have square root of 2, so I have square root of 2. Again, I can just kind of fill in what I need. So I'm going to say it's going to be 1.4142. I have 1.3, so I'd say 1.3. Since it ends there, I'm going to have the rest be zeros. Since it's 1.3 repeating, I know that I have to have 3's in those place value columns. 3 over 2 is just 1.5. And 15%, anytime you see that percent, just divide that value by 100. So we have 15 divided by 100. And so it's going to be 0.15. All right. And so the way it works is like this. what I like to do is I like to now say, okay, I'm looking for the greatest value, and you cover up and you say, okay, which of these is the greatest? Well, I have several values that are all the same, so I have to go over another place value column to compare. I'd say, okay, now out of these, which one is the largest? We'd say, hey, that 1.5 is the largest, which in original form is 3/2. So I'm going to say my greatest value is 3/2. I cross it out, I just do one line through it, that way I know I used it. And then you just repeat the process each time. So I can say, okay, now out of this list of number, which one's largest? At 1.4, which in original form is square root of 2. So we have square root of 2, cross it out. Now we have two numbers that are tied, 1.3, and so we have to move again to the right, and we'd say, okay, 1.3 repeating, and then we'll have that 1.3. So we have 1.3 repeating, we have 1.3, and then we have that 15%. So we're saying, okay, out of if this is our list of values, we have to say, okay, which of these has what we need? So we have 3/2 is going to be first. Excellent. Moving on. Same kind of setup. It says to put these in ascending order, which means we go from least to greatest. So let me clear this out a little bit for you. And so now I can use and have, let me fold this down. Always use that space accordingly. And so now we have these values here. I'm going to double check, make sure it's on screen, which it is. All right, so it says put the following values in order from least to greatest. Again, that's ascending. Again, my values are pi. We have 10/3. We have 2 7/8. We have 3.1 times 10 to the -2. And we have 115%. So this is a good one to do. It has all the different forms. We have a mixed number, an improper fraction, an irrational number, scientific notation, and percent. Excellent. So let's get the full spread. Again, same kind of setup. Put those decimals down first. I have 5 values that I need to change to decimal form. Again, I can just leave, all right, let's go ahead and use that pi button, I guess, for right now. Usually just say 3.14, but when we're comparing numbers, maybe it goes a couple more out, so 3.1415. If you run out of space, that's okay. Again, if you need to go another decimal value over to compare, that's totally fine, but for the most part, you're not gonna need more than just those first two. For the second one, we have 10/3, so it's gonna be the 3.3 repeating. Again, make sure that you are filling those in appropriately. If it wasn't repeating, you'd have to put in those zeros. For the second one, how we put our mixed number into decimals? Well, you have to be careful. Since it's a positive number, I'm gonna have plus. So it's saying 2 and we would say 7/8. A question that comes up, what happens, Mr. Shank, if that is a negative number? Well, you have to make sure that both of these are negative. So I'd have to say -2 minus 7/8. Again, you would see that, hey, that's a negative 2.875. Just be mindful of that when you're using that Desmos calculator. You have to be very careful of what you are typing in. All right, so we have 2.875. Use that scientific notation. We have 3.1 times 10 to the -2 power. So this can be 0.031. And then we have our last value, 115%, which is per 100. So we divide it by 100, and so we have 1.15. All right. Again, we're going from least to greatest for our ascending order. So now we're going to compare, okay? When you compare those values, always start at the furthest left, and we're saying, okay, out of these values, which one is the smallest? We would say 0 is the smallest, which that value in original form is that scientific notation. So I'm going to say, all right, I have my smallest number is going to be 3.1 times 10 to the -2 power. Put a line through it since I used it. Now comparing, I'd say, hey, that 1 is going to be of these 4 numbers remaining, 1 is the smallest, and so I'd say in original form is that 115%. comparing these remaining three numbers, I have my mixed number, so I have 2 and 7/8. Since I have a value tied, I have to go out another decimal place column. I'd say pi is going to be my next value. And lastly, I have my 10/3 as my greatest value. So again, make sure you're saying, okay, it's top to bottom and then left to right. So make sure you're careful on the options that I have. So we had 3.1 times 10 to the -2. We had 115%. We have 2, 7/8. We have pi and 10/3. Excellent. All right. So now, let's see. If it says to correctly place the following numbers on the number line, a way you can think about it is like this. You could say, hey, this is going to be going from least to greatest. The further left you go, it's going to be the smaller numbers since they're more negative. So a way you could do it is, if you wanted to, you could just, compare these values and say, hey, it's close to this, or you could put them in order from least to greatest, and that would also work. So let me actually do that real quick. All right. Might get that all nice and straightened out for us. All right. Make sure it's on screen. Looks good to me. All right. So now what we're saying, same kind of setup. Let's change these to decimal form. I have square root of 11, negative square root of 20. I have pi again. I have negative 47.3%, and I have negative 4 and 1/4. All right. So if you notice, hey, we have a couple, positive and negative numbers. So make sure you're saying, okay, where are we going to be at, negative numbers to the left of 0, positive numbers to the right of 0. So we can kind of use that in our head as well. So what I can do is I can place those decimals down first. I have 5 values that I'm changing to decimal form. So we can type them in as they appear. So I have square root of 11. I have 3.3166. I have the negative square root of 20. Again, be mindful of what you're typing in. It has to look exactly as it does in the problem. I just put the negative sign out front, so I have negative 4.4721. Let's have pi. We said that was let's do it one more time. Why not? We have that 3.14159. We have negative 47.3%, so we have to do negative 47.3 divided by 100. Again, whatever that value is, just divide by 100. And lastly, just like I said before, if you have that negative mixed number, make sure you have negative for both of those values. So I have the whole number, which is going to be that 4, and I have the part, which is just that negative 1/2. So we'd say it is going to be negative 4.25. All right. Now think carefully on this one. Make sure you're saying, okay, if we're going from least to greatest, we'd have to start from the furthest to the left. So what is going to be furthest away from 0? So when comparing this, I have to say, okay, I have to have a value that is going to be my lowest. And if you notice, hey, I have some positive numbers in here and I have 0. So I'm going to be furthest to the left. So I'm going to say, okay, between negative 4 and negative 4 are going to be the two numbers I'm comparing. Go one place value column out. I have negative 4.4 and negative 4.2. This is going to be further from 0. So this is going to be my lowest number, which in original form is negative 20. So I'm going to say negative square root of 20. Negative square root of 20. Put a line through it as you use it. I could say I have my negative 4 and 1/4, excuse me. 4 and 1/4. Negative 4 and 1/4. Put a line through it. My last remaining negative number is that percent, so I'm going to say negative 47.3%. Negative 47.3%. And now let's compare those last two values. So again, I can compare, all right, they're tied for 3. However, I have 3.3 and 3.1. My next value, again, make sure you're saying what out of these two numbers, which one is the smallest. We can see that 3.1 is the smallest, which we're talking about pi for that. And lastly, but not leastly, we have our square root of 11. All right, can cruising on through with that very simply. So now for number 5, make sure you can read those questions carefully. It says, which of the following inequality statements is not true? So we're looking for something that is false. So that means that 3 of these are correct. However, 1 of them is false. All right, so let's compare these values. So we're saying that 0.1%, so divided by 100, it is greater than 3 times 10 to the negative 2 power. Is this a true statement? It is not. So we have this is 0.001 is not greater than 0.03. But let me backtrack here. This is a 4, not a 2. So let's actually double check. Oh, it is not. This is actually going to be larger because what we can do is double check. I can say, hey, that Desmos calculator does go more than -3, so I can say, all right, I can move that to the left 4 times. So I'm going to have 1, 2, 3, 4. Fill in those zeros, and so we're saying 0.0003. Since I have a value that is lower than that 0.1, this is still true, so we're fine. All right, almost made a mistake, but we're good. All right, so it's not that first one. What about next one? We have 0.25, and this is the same as, and 2 over 5 is 0.4. Is that a true statement? It is. For square root of 7, what do we have? Square root of 7. So with that square root of 7, we can say that's 2.645. So this is 2.645, which is not greater than 2.7. So we're going to say, hey, this is the one that's false, which is what we are looking for. Again, we were looking for something that was not true. All right, for the next one, it says select all the real numbers that are greater than. So anything greater than -3. Again, if you need to, you can think, okay, where on the number line am I at? If I'm saying -3, anything greater than -3. So I have -2, -1, 0, still going. So use those other ideas for inequalities to help you out. So let's select all those values that are true. So what I can do is I can type these in to that Desmos calculator. So I have negative square root of 15, negative 3.87. If I think about it, since it's a negative number, that's going to be further to the left. So I need to say it needs to be to the right. So it's not going to be that one. What about the next one? I have 2.3 times 10 to the let's say -2 power. This is 0.023. It's a positive number. It's going to be greater than, so I will select this one. What about the next one? We can do -3.7 times 10 to the 0 power. Again, any number to the 0 power that's not 0 is just 1, so this is just basically times 1, which this is not greater than -3. What about -11 over 3? Not quite. What about -2 and 2 over 3? That actually does, 2 over 3. That actually does work. It'd be about right there, which is to the right of that -3 value. So we're going to say we are going to select this one. And then for that last one, we have -3.09 repeating. Since it's to the left of our -3, we're not going to include it. So just these two values. For number 7, it says select the 3 real numbers that are represented by points on the number line below. So to say, okay, where are we at on this number line? Well, let's think. Each of the marks are 5, but what we can say is this. So I could say each of the values that we have the count by 1. So this is going to be -3, -2, -1, 0, 1, 2. If you need to fill this in, that is totally fine. That way you'll at least have it, and so that way you can say, okay, what numbers do I have? Well, I'm going to have a number that's between -3 and -4, a value between 5 and 6, 11 and 12, and I'm good. So I'm looking for 3 numbers that work out. So let's see. That square root of 29, we have 5.38. So let's say 5.38. That could be a possibility. So I'm going to say, hey, I'm going to have, this is the square root of 29. All right. Then for, what about negative square root of 13? That's negative 3.6. So where is that going to be? Well, that's below that -4, so that could also work. So I could say it's negative 3.6. So I could say negative square root of 13. What about that square root of 123? That's a little bit above 11. Well, if you notice, hey, it's going to be in the middle of these two values is 11.5, so it should be to left. So I'm going to leave that go for right now. What about that square root, or that negative square root of 21? We have negative 4.58. Not quite, because that's going to be further out, so it's not that one. What about square root of 139? Where's that at? We have 11.78. So this is probably going to be more realistic because, like I said, that halfway point is that 11.5. And so we could say, hey, I think this one is going to be right there. And then lastly, what about the square root of 23? We have 4.79, which is in between 4 and 5. And so we'd say we're not going to include that one there. So we're not using that one. Not using that one, but we are using those 3. For number 8, it says, which of the following could not be placed in the blank to make a true statement? So we're looking for, again, not a possible answer. However, we can say, all right, we have 2.3 times 10 to the negative 2 power. So this is going to be the same as 0.023. We're saying, okay, we need to find a value that's greater than that, but less than the 1.7. So as we're changing these values over, we can say, all right, we have 25%, which is 25 divided by 100. So we have 0.25. That would work out, but we're looking for one that does not fit. We could say 1 and 2 over 3. So that 1.6, that also works out, so it can't be that one. What about that 3.5 times 10 to the negative 1 power? That's 0.35, which also would work out. How about this last one? This should be greater than 1.7, which it is. So this is 1.875, which is greater than this, so that's why it could not fit. For number 9, it says select each number that is between these two. So I have 535%. So this is going to be my values between, let's say, 5.35 and a value between, we're just going to be, say, 6.01. All right. So let's see. What could I place in this blank like we had before? Well, we could say, okay, this one would work out. This is just going to be 0.6. That would not work out. What about 47? 47 over 8. It's 5.875. This is 0.6. 5.875. That actually would work out. However, 5.3 would not work out since we had to have at least at 3.5. This is 0.6 again, which would not work out. And what about the square root of 35? Square root of 35. And 5.9 looks good to me, and so we would include those as well. And then lastly, it says which of these is the largest? Well, I can still use that same strategy I used before, so let me get it one more time out here. Get it one more time. All right, so it's saying, let's compare and find the one that is the largest. So again, I can say I have 7.3 times 10 to the negative 1. I have 2 over 3, 47%, and 0.32. Again, I can change these values to decimal form. That way they are easier to compare. So I have, put my decimals down first. I only have 4 numbers I need to compare. It's a little bit easier. So this is going to be that 0.73. This is 0.6 repeating. This is 0.47. And that's already in decimal form, so we're good. So now we're saying, okay, out of these values, which one is the largest? So again, you can compare and say, all right, as those line up, you'd say, which of these is largest? We'd say that 0.7 is the largest, so we're going to say A for that one.